Hi, I'm Colin Walls and I'm here once again to talk about embedded software. Today I want to talk about power management. Developing devices which consume less power is something which many engineers are involved in, and as we have more portable equipment and increasing concerns about the environment, consuming less power is an important matter. In the past, it's been considered a hardware issue. After all, it's the hardware that consumes the power, so it must be a hardware problem minimizing that power. But it turns out with most embedded systems, the power consumption can vary depending upon what the device is actually doing at a particular time. This means that the software needs to be able to have some influence on the power management. Now, this requires the hardware to be designed in such a way that the software can do this, and that's not particularly difficult to do. There are three areas where software has an influence on power management. First of all, you have a CPU, you have memory, and you have a bunch of peripherals. Those peripheral devices will not necessarily all be in use at any one time. So if the software can determine which ones are needed and switch off the ones which are not needed, that will save power. That's pretty straightforward. It just means the drivers for those devices need to be power management aware. So that's an easy one. The second thing software can do is exercise a facility called DVFS, Dynamic Voltage and Frequency Scaling. The idea here is reasonably straightforward. It may not be obvious to the average software engineer, but if you reduce the frequency of a chip, you reduce its power by a substantial amount. Now, of course, reducing the frequency of a CPU means it can get less instructions done in a given period of time. So reducing the power might be quite unattractive. But there are times when there isn't much work for the CPU to be doing, so by winding down the frequency and the voltage potentially, you can reduce the power consumption when all that performance isn't actually needed. Number three is most CPUs have some sleep modes of some kind. Now those modes will vary from one chip to another, but broadly speaking they enable you to shut down the CPU into some sleepy state from which it can be woken when it needs to do something. And obviously once it's asleep, power consumption will be dropped drastically. There are, broadly speaking, two kinds of sleep modes. There's one which is commonly called standby. Now standby is when everything in the system is shut down except the memory. The memory is kept alive and hence needs a bit of power, so that when the CPU starts up again, it can start executing code immediately because the memory is up and running. That's quite useful because you don't spend too long getting into standby mode and you can come out of it very quickly. An alternative, which saves you more power, is called hibernate mode. Now in hibernate mode, when you enter this mode, all the memory is stored somewhere safe. On laptop computers, that's normally on the hard drive, but in an embedded system, you'd store it in flash most likely. Once you've stored all the memory safely, the CPU and everything, memory as well, is shut down. When you start up again, of course, the memory has to be restored out of the non-volatile media that you're keeping it on, and then the system can run as normal. These modes sound really useful. You think you should drop into a sleep mode whenever you possibly can. And broadly speaking, that's true. However, you do need to be careful because a certain amount of power is consumed getting in and out of sleep modes, particularly obvious with hibernate, where you'll spend some time and hence execute a bunch of instructions, which in turn consumes power, getting into hibernate, and then you do the whole thing coming out of it again. So you may actually expend more power getting in and out of hibernate than you saved by being there. So you need to have a very careful look at the use case as to whether going into hibernate is going to keep you in that state long enough to save enough power to make it worth going there in the first place. Power management is quite a big subject. There's a lot more to be said about it. It's the kind of thing I've written about quite a lot, and I will probably appear here in due course with some more topics on power management. But I hope that gives you a flavour for what software can do. That's it for today. I'll be back again soon with another video about embedded software, and I'll see you then. Bye for now.